Hi fellas, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well, now we're gonna solve another question of this of the previous tutorial. Okay, another part of the question of previous tutorial. So here is another equation. Okay, so if you have missed the first part, don't need to worry. I'll put the link at the end of this video. Okay, so stay tuned. So here we're gonna choose the suitable method for uh, investigating rate of this reaction. We're gonna choose the suitable method to investigate the rate of the reaction. Okay, so let's see. So methods for investigating rate reactions include colorimetry. Option A is colorimetry. Collecting. Option A is colorimetry. Option B is collecting and measuring the volume of a gas. Then option C is method. Quenching method followed by titration with acid. Option D is quenching followed by titration with iodine solution. Okay. The question said which method would be the most suitable to investigate the rate of the reactions. Okay. So let's see. So at first let us analyze this equation, this chemical reaction. Okay. So as you can see that here is hydroxide is present. Okay. And here is bromide is present. These are the two key species of this reaction. Okay, so this hydroxide is reactant and this bromide is product, as you all know. Okay, so our main objective of this solution should be regarding this hydroxide. Okay, so let's choose the suitable method. Okay, so let's see whether colorimetry is suitable for this method or not. Okay, so as you can see so as you can see, this is bromoalkane, and as you all know that bromoalkane are colorless. This is colorless. Okay, this is a colorless solution. These both bromoalkane and hydroxide are colorless solution. Okay, so reactants are colorless. So reactants are colorless. So now here reactants are colorless. So now let us move on to the products. So as you can see that these are also colorless. This is alcohol and this is bromide ion. So these two solutions are also colorless. Okay, these two products are colorless. Since reactants and products are colorless, reactants as well as products. Okay, since reactants or products are colorless, so it is worthless by carrying out the colorimetry method to investigate the reaction rates. Okay, so option A is cancelled. So it is not applicable to follow the rate of the reaction by colorimetry method, since since the whole solution is colorless, since the reactants as well as the products are colorless, so colorimetry is cancelled. Okay, is invalid for this situation. So let's move on to the option B. So in here, since these all are, since as you can see that there is no gaseous substance present in reactants as well as products, so we can't measure the volume of a gas, since these are all not gas. Okay, since this is liquid, since this is hydroxide, since this is liquid, and this is aqueous. Okay, so since there is no gaseous state, there is no sorry, there is no gaseous substance. Okay, there is no gaseous substance, so for this reason we can't uh, investigate rate by following this method. So this method is also cancelled. Okay. So let us move on to option C. So let's see whether this is suitable for this condition or not. Since hydroxide is present over here, okay, so hydroxide is present. Since hydroxide is present, so we can carry out quenching followed by titration with acid. At first we're gonna stop this reaction, freeze this reaction, then we will carry out the titration method. Okay, so in here quenching means stopping or freezing more specifically. Okay, so since quenching means stopping as well as freezing, so at first we're gonna freeze or stop the reaction, then we will carry out the titration with acid. Okay, so this is how we're gonna do the experiment, and we will repeat the experiment, and we will find the we will plot the graph. We will do some analysis, data analysis. We will do some data analysis and plot the graph, and finally we will calculate the rate by this method. Okay, so why we can carry out this method? That's because this third method, that's because hydroxide is present, so we can carry out the titration with acid with hydroxide. Okay, we can carry out this hydroxide acid titration. So hydroxide can be neutralized by this acid, so that's why we can carry out this method. So that is why option C is valid. Since hydroxide ion is present, so we can carry out the titration with acid. Okay. Since hydroxide is one of the reactant, we can titrate it with acid. Since hydroxide is one of the reactant, we can titrate it with acid. Okay. So let us move on to the next option, D, quenching followed by titration with iodine solution. Well, it's it's looking quite confusing whether D should be the answer or not. Let's see. Since here is iodine solution, we can't have this as displacement reaction. Since bromide ion is more reactive than iodine, so we can't have this displacement reaction. Okay, if there was chlorine or fluorine solution, if we are to titrate this with fluorine solution or chlorine solution, then this option might have been valid. But since we are using iodine solution, which is less reactive, which is less reactive than bromide, iodine is less reactive than bromine. So iodine can't displace bromide from its compound, so that's why we can follow this titration. Okay, so we can carry out this displacement reaction. So since bromide ion is more reactive, okay, since bromide ion is more reactive than iodine, so iodine can't displace bromide ion from the compound, so displacement reaction isn't possible. Displacement reaction is not possible. So that is why displacement reaction is not possible. Okay. Since iodine is less reactive than bromide, that is how. Okay. So bromine is more reactive than iodine. Bromine is more reactive than iodine. Let me repeat this again. Since bromine is more reactive than iodine, so we can't have a displacement reaction. Therefore, this option is invalid. Okay. So the option should be uh, so the option should be C. Okay. So the option should be C, which is quenching followed by titration with acid. Okay. So the option is C. Well, fellas, this is the end of this tutorial. So If you have any question regarding this topic, please let me know in the comment section. Or if you have missed the previous episode, you don't need to worry. I will put the link at the end of this video. So fellas, that's it for today. So signing out. Best of luck, fellas. Best of luck, fellas. Best of luck. Hoping you best of luck, fellas. And peace with chemistry.